Hello friends, I Professor Darshan Thakur from Terna Engineering College Dharashu welcomes you on my YouTube channel for this subject head digital communication. Friends, as far as our today's session is concerned, so let us try to continue our discussion on this spatial modulation scheme whose name is nothing but the spread spectrum technique. Now as far as this spread spectrum technique is concerned, so already we had discussed the basic mechanism behind this spread spectrum technique. So according to its definition or the objective behind this spread spectrum technique is to enhance the bandwidth of this transmitted signal as compared to the input signal over a larger frequency band. So this is the main objective behind this spread spectrum technique. Now as I told you earlier, this spread spectrum technique, what exactly we are doing, if suppose this is only for our convenience, if suppose this is the spectrum of that input signal whose bandwidth is exactly equals to B. So whenever it is being passed through this spread spectrum modulator, so after that what exactly we are doing? We are enhancing the bandwidth of this transmitted signal over a larger frequency band. So whose bandwidth is exactly equals to what? L times of B. That is nothing but what? The spread spectrum bandwidth, where this L is nothing but what? The spreading factor, so obviously which exactly equals to bss upon B, right? Now as I told you earlier, this spread spectrum technique equally works in case of analog communication as well as in digital communication. If it is configured in case of analog communication by taking into account the length of the spreading sequence, because how that bandwidth is being enhanced, the bandwidth is being enhanced with the help of this spreading sequence or with the help of the pseudo noise sequence, right? So here L equals to what? It is the ratio of the bss upon B, where bss is nothing but what? The bandwidth of that spreaded signal, and capital B is nothing but the bandwidth of that unspreaded signal or the input signal, right? So when it is being configured in case of analog communication, so that spread spectrum technique, that can be called, it is as a frequency whole spread spectrum, and when it is being used in digital communication, so that can be called, it is as a direct sequence spread spectrum technique, right? So as far as our today's area of discussion is concerned, we will try to discuss the basic mechanism belongs to this direct sequence spread spectrum technique. Okay friends, so let us quickly go through the direct sequence spread spectrum modulator or the direct sequence spread spectrum transmitter, and these are the relevant waveforms belongs to this whole process involves in case of this spread spectrum mechanism, right? So as you can see, this is how the direct sequence spread spectrum modulator will look like. Now see, as far as this direct sequence spread spectrum technique is concerned, or the frequency of spread spectrum technique is concerned, means either it is analog spread spectrum technique or the digital spread spectrum technique. Always it involves the two steps of modulation process, because as far as this modulation is concerned, so already we know that it is the process in which how we are converting that information bearing signal in a form which is suitable to that fellow whose name is nothing but what? Channel, right? So whether it is analog spread spectrum technique or the digital spread spectrum technique, always it involves the two level of modulation, right? So as you can see, let us begin with this input signal, or we can call it as a information signal, right? So these information signals are being given to this first modulation step, or as you can see, the name given to this block is nothing but what? The phase shift gain modulator. Means either we can have the single carrier or the multi carrier continuous wave digital modulator in this first level of modulation, right? So as I told you earlier, it involves the two different levels of modulation. So within that first level, we can have the continuous wave single carrier or the multi carrier modulators, right? In order to involve the desired information bearing signal which we are interested to transmit from source to destination by the virtue of this spread spectrum modulation technique, right? So either we can have the phase shift gain, or either we can have the QPSK modulator, or either we can have the quadrature amplitude modulator or the quadrature amplitude shift gain modulator, QASK modulator, right? Now after going through this first level of modulation, now how this first level of modulation occurs, already we had discussed the phase shift gain modulator, QPSK modulator or the QAM modulator, right? So let us not waste our time in that first level of modulation. What is important for we people is to understand how we are going for the second level of modulation. Within that second level of modulation, what exactly we are doing? So after going through the first level of modulation, the desired symbols or the signals, those are being emitted by either the single carrier continuous wave digital modulator or the multi-carrier continuous wave digital modulator. These desired signals are being given to one of the input of the second modulator, or we do can say that the fellow whose name is nothing but what? The spreader, or we do can call it as a one type of amplifier also, because this desired symbol sequence is being combined with this lower terminal of this modulator, which consists of this chip generator, which is being operated by this PN sequence generator, or we do can say that the spreading sequence generator, right? Now one question arises in our mind ki what this PN sequence or what is the role of this PN sequence, because by means of this PN sequence the bandwidth of signal or the bandwidth of this proposed transmitted signal is being enhanced. So we do can say that this is the deterministic signal. This sequence is nothing but what? This is not the random signal. By taking into account certain logic, this sequence is being selected, right? Once it is being selected, then through this chip generator, these signals are being given to the lower terminal of the second modulator, right? Then after that, what exactly we are doing? As we know that here L is nothing but what? The length of that spreading sequence. In case of this analog system, it exactly equals to bss upon b. But when we talk about the digital spread spectrum technique, so in that this L equals to what? It is the ratio of TB upon TC, right? Where TB is nothing but what? The bit duration for each 1 and 0 belongs to this modulating signal. And what this TC stands for? This is nothing but what? The chip duration belongs to this spreading sequence, right? Graphically also we do can say that, as you can see, during each and every signaling interval, these two signals are being multiplied with each other, right? Which two signal? The signals those are being emitted by either single carrier or the multi-carrier continuous wave modulator, and the second signal is nothing but what? The desired spreading sequence, right? So in this way, we do can generate the resultant signal which is to be transmitted by this dsss transmitter here. So in this waveforms, as you can see how these two signals are being multiplied with each other in order to increase the bandwidth of this proposed transmitted signal which we are interested to transmit. Because one more time, let us quickly go through the expression for this spreading factor, which exactly equals to what? It is the TB upon TC, right? So obviously TB is nothing but what? The bit duration for this input signal belongs to each 1 and each 0, irrespective of number of 1s and number of 0. TB is nothing but that much amount of duration that bit is being transmitted by that modulator, right? And this TC is nothing but what? This TC is nothing but the bit duration for this chipping sequence, right? Now as these two signals are being multiplied with each other, means what? In case of communication, we are going to perform the XNOR operation in between these two symbol sequences. Which two symbol sequences? The input signal is nothing but what? The signals those are being given by this single carrier or the multi-carrier continuous wave digital modulator, and this is nothing but what? The desired chipping sequence provided by this PN sequence generator, which is connected to the lower terminal of this second modulator to generate the desired or to generate the resultant signal belongs to this direct sequence spread spectrum technique, right? Now, so as we know, in case of this XNOR operation, if suppose it is the two input XNOR gate, so 0 0 0 1 1 0 and 1 1, right? If suppose this is A and if suppose this is B. So as we know, in case of this XNOR operation, when these two inputs are same, at that time its output is high, otherwise its output is 0, right? So for 0 0 it is 1 and for 1 1 it is 1. So we need to follow that XNOR operation. So as you can see here, the first bit is nothing but 1, second is 0, and then after that third bit is nothing but what? 1. Okay, so for this bit duration of TB, this chipping sequence is being XNOR with binary 1, binary 0 and binary 1, because here the input signal consists of 3 identical bits. And as far as this chipping sequence is concerned, so as you can see, the length of chipping sequence or the length of spreading sequence is how much here? The spreading sequence is like this. Here I will write it is 0, 1, 0, 1, 1, right? 0, 1, 0, 1, 1. So 1, 2, 3, 4 and 5 means capital L equals to how much here? Capital L equals to 5. The length of chipping sequence or the length of spreading sequence is 5. There are 5 identical bits by taking into account certain logic for the purpose of transmission from source to destination. Now, to generate the desired output signal, or in order to have the desired output code or the output waveforms, what we need to do, as I told you earlier, there will be a bit by bit XNOR operation, right? So when this whole sequence is being XNOR with this binary 1 for this bit duration, so it will become what? 0 XNOR of 1, 0 XNOR of 1, it is 0, right? 1 XNOR of 1, 1 XNOR of 1 is how much here? 1. So 0 XNOR of 1, again it is 0. So the same sequence is repeated here, because whenever this entire sequence is being XNORed with this binary 1, so we are having the similar sort of output here. But whenever the same chipping sequence is being included within each and every bit duration, so the chipping sequence is like this 0, 1, 0, 1, 1, right? So when this 0, 1, 0, 1, 1 is being XNORed with this binary 0, at that time what will happen? Because see, 0 XNOR of 0, 0 XNOR of 0, it is 1. Whenever we are having the two similar inputs, at that time the output of this XNOR gate is high, otherwise it is 0. So 0 XNOR of 0, it is 1. 1 XNOR of 0, obviously it is 0, which is being shown. So 0 XNOR of 0, again it is 1. And for 2 times we used to have this binary 1. When it is being XNORed with this 0, so obviously it will become 0. So just this portion is nothing but what? This portion belongs to binary 0 is nothing but what? The complement of the previous portion, right? Because in that previous portion, which bit we are interested to transmit? 1. Here 0 and again 1. So in this way, such type of the desired output code is being generated by this direct sequence square spectrum modulator. Now as far as this demodulation process is concerned, so in case of this demodulation process, this is our desired signal denoted by this direct sequence spread spectrum signal, right? Now this, when this signal is being transmitted, so at that demodulating end, first of all, because again we used to have the coherent type of detector, so for once that signal is being transmitted towards the receiver, so at the first end of this receiver, these signals are being despread, right? So for that despreading process, the same PN sequence is being adopted by this demodulator, right? The similar sort of PN sequence. Here the PN sequence is nothing but what? 0, 1, 0 followed by 1, 1. So in this way, there will be the process of demodulation, right? Now as far as the applications are concerned, so already as we know that from application point of view, for that purpose we need to recall the necessity of this spread spectrum technique. So as we are very much aware of this thing, the main objective behind this spread spectrum technique is to effectively utilize the available transmission bandwidth, right? So that is one of the most important resource of this communication system is concerned, either it is analog or digital. So effectively we need to utilize the available transmission bandwidth, right? So this spread spectrum technique is being adopted by the different multiplexing technique or the multiple access technique. Like multiplexing techniques are nothing but what? Time division multiplexing or frequency division multiplexing. But this spread spectrum technique is adopted by this multiple access technique, whose name is nothing but what? The code division multiple access. So this direct sequence spread spectrum technique finds application in terms of this code division multiple access scheme, which is used in case of this 2G as well as 3G terminologies in case of this telecommunication industry, right? So this is how this direct sequence spread spectrum technique or the digital spread spectrum technique works. I hope you had understand all these things with this graphical representation. Thank you.